Hello YouTube, so today we are going to be doing a demonstration of this circuit we have right here. What this circuit does is it basically has an LCD and a numerical keypad, and what happens is when I press one of these buttons it will show up on the display, the number that I press. So just to demonstrate, 1, 2, 3, 4, 5, 6, 7, 8, 9, star, 0, and a pound sign. So how this works is, if you're not familiar with these keypads, is that it's not like for each button there's a wire. Uh, if you're paying attention, there's only 7 wires and there's 12 keys. So what it actually does is it separates it into columns and rows, and we have 3 columns and 4 rows. So if you actually see it right here, your 3 columns are here and your four rows are on this other side of the wire. And that makes it a little bit more difficult to actually use this rather than just have a bunch of buttons go in. But on the reason why you do this is because it allows you to use less cables, and it reduces the amount of cables without any circuitry really going on around here. You don't need a shift register or anything. You just have a few wires. And how this actually works is that the 4 rows are going to the inputs of the Arduino. They're going to the analog inputs, but I'm using them as digital inputs. So what happens is when I press a button on this row, or a button on this row, or a button on this row, or a button on this row, the respective wire will go high. So if I press this one, or this one, the wire for the 4th row will go high. If I press any one of these, the wire for the 1st row will go high. Same as this for the 2nd and 3rd row. So that allows us to know which row is on if we are passing a positive voltage through the 3 columns. So if all 3 of the columns have positive voltage, when I press any one of these 3, the row will go high. But of course, that doesn't allow us to see which button is being pressed. So what I'm actually doing is I'm cycling through each column. So we're going basically this one, this one, this one. So it's first row, second row, third row, first row, second row, third row, as the LEDs show. And what that does is, as long as I'm pressing this button, it will only show up as high when the respective row light is on. I don't know if I'm explaining this properly, but basically what it does is it allows me to press any one of these buttons, and the Arduino will understand which button has been pressed. And that's how that works. Well, let's actually go look at the code now. I'm not gonna do a screenshot because I want to make this video quick. So here's basically what's going on. A lot of this is from the library for the electrofluid crystal display, and we're setting that up. And then we have some variables right here we're setting up, or constants. You have our columns and our rows, which rows we're on. And as you can see, the columns are outputs, the rows are inputs. And here we're actually setting up a timer interrupt, and we're going to do more on that later. So we're going to start the LED, and it's going to display hello world. Just start it. Here's a function right here to scan the key. Basically, I wanted something that would work like how scanf does, or cin in the C library. Just very simple like that, where you just prompt it to scan, and then it will wait until you press an input, and then it'll go like that. So what this does is it's void, so that means that the only it doesn't produce an output. What it does is it actually does output the value you press, but that's being passed by that value is being passed by a pointer. So you can see this is a pointer for the input, and it is also an integer. So that means that if I press any one of these buttons, the output will be an integer. Alright, so for these numbers, it makes sense, just pass the number that's being pressed. But of course these two are going to be a bit different. So what I actually did is this one's like, this one is going to pass 11 and this one's going to pass 10. And I can do that because if it's a number, then it's going to be a single digit number. So if it's receiving a double digit number, then that means that it's either this or this, and that's handled later in the code. But let's just to see this for now. It's basically just a bunch of these statements. So actually, I think I'm gonna go look at the interrupt first. And what this says is there is a global variable for the column, and it's basically gonna. This is a timer, so at a certain amount of time, it's going to execute this code, which means that it's going to switch this column, and the column starts out at 0, and if it's 0, then it's going to have the first LED, it's going to turn on, and then, well, it's going to look at the first column, there's a high, low, low, then it's going to look at the second column, low, high, low, and then it's going to look at the third column, low, low, high. And then during each of these, if it's setting column to 1, so that means next time go look here, and this means next time go look here, as the switch works. So now that I've explained that, we know that the column says which column we're on, either column 0, column 1, or column 2, which is column 1, 2, 3, or 3, just ignore that. I numbered it differently. And what it's doing here actually is we're going to do a digital read, and that means that we're going to read all of the row values, and then we're going to store them here. And this happens while none of these are high. So the code is going to stay in this loop until a button has been pressed. And then what it's going to do is it's going to see, okay, which button was pressed. Was it row 1, row 2, row 3, or row 4? And now that it can see the row, it has to determine the column, and then we know which button was pressed. So by determining the column, we can switch the column, which tells us which column we're on at any point in time. And remember that the button for these values can only be pressed when this is on. Otherwise, it would just go to ground and be voltage. So what this does is it's just going to determine what the input is. It could either be 3, 2, 1, 4, 5, 6, 9, 8, 7, or 10, 0, or 11. So as you can see, this keypad, it only goes from 0 to 9, so 10 and 11 are these buttons. And we're going to determine that here by switching this again. And if it's 10, it's going to print a star, and if it's 11, it's going to print the pound sign. By default, it's just going to print the integer input. So what you wanted to do with this is just have a keypad that I could enter in stuff to an Arduino, so I could run code on the Arduino that you run on a PC, for example, like a calculator application. And what this allows me to do is it does allow me to press the buttons. One thing that I have to do is I have to hold the button down for a long time because it has to match up with the LED. So one thing that I can do is I could just simply make the clock go faster, and this has to do with this variable right here, or this value, to the register to set the timer. This code is just stuff I pulled off of an example for the timer interrupt.
So we can just make this 10 times as fast by getting rid of that 0.
And now it's probably going to be hard to even see it. Yeah, so now it's switching through really fast, and it's basically what that's going to do is it's going to allow us to press these buttons. And you can see that I have to hold them for a lot less. And I can make this even faster. It could go up to the clock speed of the Arduino, or just about. There is a limit on how fast the timer can go, but the clock speed of the Arduino is a couple of megahertz. Your hands don't move very fast, so it's really easy just to enter whatever. And one thing that I kind of want to do is I want to see if I could get a larger keyboard. Like this just allows numbers and 2 other buttons. But say for example, if I want to make a calculator, which is something that I could do with this, you can see I have an LCD and a keypad. I could make a calculator with this, but that would require more buttons for the functions. I could, I guess, scroll through them with these, but yeah, that's something I'm gonna try later. But this is just the keypad that I have. You can buy these pretty inexpensively. They do sell models that have 16 keys, and then that would just be a 4x4 matrix as opposed to a 3x4 matrix. And then there's also stuff like this keyboard, for example. And let's say that if I want to get a keyboard of this size to work on an Arduino, that would require a shift register, because even if I did matrix these, that would have an issue of still using too many pins. And also there's another issue, is that you can't press multiple buttons on these at the same time. Well, you can, I think. Well, that's something I'm not sure, but this code can't handle. And yeah, if I wanted to use a keyboard, I would use a shift register, and that would shift through all the inputs. Or another thing that I'm thinking about doing is having a keyboard that would, when you press a key, it would enter the 8-bit ASCII value for that key, and then that would only use 8 pins. And with that, I could have 127 inputs. Well, also one for no input, or 0, and that would use basically just a little bit more than these. So yeah, this is 12 values, and if I wanted to make this just have a binary output, that would have 4 wires. So yeah, by no means is this the most efficient with wires. You could make this output for serial, and that would only use 2 wires, but once again, this is just a simple matrix. So yeah, that's what I've been working on right now, and that's how to use a keypad on